We discussed all of it, but only this last question
Yes,
was
teacher, we
left.
discussed earlier.
Dot and cross structure of
No, teacher, we discussed
chlorine
till the end.
molecule. Yeah, we discussed till the end. This one also I told you, dot and cross structure for chlorine.
No.
No, I don't think so.
Yeah, because this is your presentation, huh? So I remember that some of the last questions, they are left. So let's see. Not responding. Wait. Okay, dot and cross structure for chlorine molecule. For this one, I hope all of you or most of you have done the worksheet, have completed the worksheet. Just check that in this one for chlorine,
Yes, done.
the diagram is on page 85. Okay, the diagram of chlorine is on page 85. I think it's the second diagram, dot and cross diagram for chlorine. Okay, where there are two chlorine molecules, two chlorine atoms. Okay, and they are sharing their one electron. Okay, dot and cross diagram, and in that picture in the book all of the shells are made. Okay, so it's your choice. You can make all of the shells or you can make only the outermost shell. The outermost shell is important. Okay, and electron and cross okay. Define double covalent bond. How do we define double covalent bond? Are you here with me, girls?
Yes, miss.
Much same type of atom, they can be different also, but when they share two electrons with each other, then that's double bond. Okay, girls, single covalent bond, double covalent bond, and triple covalent bond. These three are the types of covalent bond. Okay, single covalent bond is when the atoms share one electron with each other. Okay, means a pair of electron. When they
In
share
two
a
pairs.
pair of electron. Yeah, when they share a pair of electron, this one. Okay, and double covalent bond is like this, when each atom share two electrons with each other. Okay, means they share two pair of electrons, two pairs of electrons. Okay, and in triple covalent bond they share three pairs of electrons. Okay, like we made the structure of nitrogen. So in nitrogen, each nitrogen shares three electron. There are three electrons. Okay, so three pairs of electrons. So double covalent bond, we'll define it as um, a covalent bond. Okay, write the definition. A covalent bond in which two pairs of electrons or four electrons are shared between atoms. Okay, so please everyone note it down on the worksheet, and if you haven't submitted the worksheet yet, please submit it. Okay, a covalent bond in which two pairs of electrons or total four electrons are shared between atoms.
Teacher, I wrote from the book. I wrote the answer from the book. So I wrote each pair of electrons in the overlapping shells is a covalent bond. A double covalent bond is made up of four two pairs. Is that correct?
A covalent bond is made up of four
A double bond is made up of four electrons, and in the bracket I wrote
four
two pairs.
electrons. Oh yeah, okay, fine. You can write four electrons or you can write two pairs of electrons. You can write any one. Okay, and the definition is
So,
also
teacher,
written
my
somewhere in
definition
here.
that I just told you is correct.
Yeah, it's correct. is correct.
Okay, teacher.
Miss, I
Okay.
just wrote the definition, which is like double covalent bond is made up of 4 electrons or 2 pairs.
Yeah. Good. Double covalent bond is made up of 4 electrons or 2 pair of electrons. Okay, in the blank also, fill in the blank also is the same. Okay, draw a structure of carbon dioxide, and this is also on page 85. Okay, of carbon dioxide, carbon is in the middle and 2 oxygens on the side. Okay. No, H2O is the Mickey Mouse structure, but carbon dioxide is straight. Okay, carbon dioxide is a linear structure. So there is a difference. Like H2O, girls, remember that H2O is a V-shaped structure. Okay, means it's a Mickey Mouse like this with 2 ears. And carbon dioxide has a linear structure, straight structure. So carbon, double bond oxygen, and double bond oxygen. It's like this, straight structure. Done?
Yes, teacher, done.
Okay, now let's start chapter 7, the new chapter, metals and structures. The 3 pages which are included are page 96, 98 and 99. These 3 pages are included in this chapter.
That's it, teacher. Only 3 pages.
Sorry?
Teacher, only 3 pages. Only 3 pages you will do.
Yeah, only these 3 pages are included. Okay, Beta, just give me 2 minutes, okay? Open the book, give me 2 minutes. I'm requested to write down the total number of students who are attending the classes from outside the kingdom. क्या होगा एक किंगडम से बाहर कौन क्लासेस ले रहा है मुझे तो पूछना पड़ेगा बच्चों से
आप अपनी लिस्ट ले देंगे
हाँ
तो साइन करते हैं फिर बाद में जब आप लिस्ट देंगी तो फिर आप उनको बता देंगे
अच्छा और ये क्या है
मेरा हर इसी पे आपने नंबर तो स्टूडेंट लिखने हैं
हाँ यू आर काइंडली टू वेरीफाई द स्टूडेंट्स who are attending the classes on अच्छा ठीक है मैं भी लिस्ट ले लेती हूँ और फिर मैं इसके ऊपर लिस्ट के ऊपर मेंशन करके उनको वापस
हाँ
ठीक कहा है ना उन्होंने
जी जी
ठीक है मैं लेके साइन जी सबने साइन किए हैं टीचर्स ने
नहीं समझ आ रही है तो वो अच्छी बात है
अच्छा इसी के ऊपर लिखे सारा
काम देते हैं
हाँ सारा को फिर सबमिट कराऊंगा
नहीं मिस सादिया नरगसिया मिस पर आपको
ठीक है
मिस सादिया को
ठीक है मैं इसके ऊपर लिख के ना मैं पता करती हूँ आज जो फ्री पीरियड होगा ना उसमें पूछ लूँगी मैं थैंक यू राजी okay yes beta now page number 96 first one metals and structures the introduction okay first we discussed about metals and non-metals and they form ionic bond we discussed that there are two different type of elements the main elements which are present in the periodic table metals and non-metals okay the metal when a metal combines with non-metal it makes ionic compound okay which we discussed in chapter 5 when non-metals form bond with non-metals they form covalent compound okay non-metals and non-metals now only metals are left okay so the metals they don't form compounds with metals form mixtures with each other okay because metals are solid at room temperature all the metals are solids okay so the solid thing like if we have solid blocks if for example if some blocks are of sodium some blocks are of magnesium some blocks are of zinc okay so we have different blocks now all of them are solid so we cannot add them together means they don't combine with each other because their particles are closely packed. The force of attraction is very, very strong, so they will not form compounds. Okay, so remember that metals don't form compounds with metals. Okay, metals don't form compounds with metals. Metals only form mixtures. Okay, and we will see that how the mixtures of metals are formed. Okay, right now in the introduction, it's written that like all around you, almost all of the things they are made up of metals. Okay, the solid things which you can see, they're made up of metals. Now in this picture, how many things are made up of metal? And which thing? What is this?
Teacher, 11 things.
Hmm. What is this? On which I just made a square.
Teacher, 12
This is
things are
pointing
made up
towards
of metal.
wire. It's pointing towards wire. Okay, so wire is made up of metal. This doorknob is made up of metal. Okay, these taps are made up of metal. And whatever, what
Teacher,
is this?
what's there behind the door? There's some white thing behind the door.
Be- Yeah, this one? I don't know. What is it?
Yes, this one.
What is this? Can you see clearly from the book? What
Teacher,
is this?
I can't see
What is
clearly
it?
from the book. It looks like a vent.
Like ventilator something? Okay, a vent. So
Yeah, it
maybe
looks
a,
like a vent.
okay, dustbin also, Bunsen burner, okay, and these handles also, door handles and tripod stand. Like most of the things, they are made up of metals which are around us. Okay, so so these metals, they are really important to study as they all are solids at room temperature except only one metal which is mercury. Okay, we all know that mercury is a liquid at room temperature. Where is mercury present?
In
Mercury is,
thermometers.
yes, liquid mercury is present in thermometers. Apart from mercury, all of the metals are solids. Okay, think of some of the things around your home that are made of metal. Did you include all the wiring, any radiators, your hot water tank, or your cutlery or pen and pans? Okay, all these things, they are the examples of substances made up of metals. Do you know which metals these things are made from? We know some of them, right? Like wires. Do you know electrical wire, that which substance is, like wires are made up of which substance?
No.
Sorry, say it again.
No, teacher, I
Wires
don't
are
know.
copper. Okay, most of the wires are made up of copper.
But teacher,
Copper
doesn't
wires.
copper conduct electricity?
That's why it is used in wiring, beta.
Yes, so teacher, it can give you a shock if you touch the
No,
wire.
no. Yeah, wire is made up of copper to conduct electricity, and you must have seen that wires are never naked. They are always covered with plastic or rubber,
Yes, the
right?
wires are covered with rubber.
Huh?
Yes, yes, okay.
Yeah, because so that you won't get electric shock, no? That's why
Yes.
they are covered with rubber because
Yes, okay,
rubber,
teacher, I got it.
yeah, rubber or plastic, it's an insulator. It does not conduct electricity. So that's why it's
Yes,
always covered. Like in pans also, the cooking pans or cutlery items, the cooking range, those things, they are good conductors of heat. So they are also made up of metal. So metal, it conducts heat also. It transfers heat. That's why the pan handles are made up of, they are covered with rubber or wood. Okay, sometimes or plastic also.
yes,
So these things, the metals are good conductors of heat and electricity. Okay, so they are covered with some insulating material to avoid the shock. Okay, which properties make metals good for these uses?
okay.
Because most of the
Teacher,
substances are
because
made
they
up of,
conduct electricity.
yeah, but it's not only about wires, it's other substances also. Okay, the taps, the stand, dustbin, okay, all these things, that there is one common property because of which all of these things are made up of metals. These substances, yes, solid and hard structures. Okay, all these things, we have to make these things super hard to make them use. Okay, so that is why all the metals are solid and they are hard. So this one property is common in all of these substances. Okay, but their other purpose is different. Like for the pans, the metal used in pans is for heating purpose. For the wiring, it's for electricity, because of electricity. And the car bodies or aeroplane bodies, they are made up of aluminium metal because they are light in weight. Okay, so but because of different properties, their metals are used in different things. Okay, but the common thing is that they are hard and solid. In the last two chapters, we have looked at ionic or covalent bonding, but the atoms in a metal are held together in a different way. Okay, so in this chapter, we'll study about metallic bonding. Okay, third type of bonding. Okay, now first we will study the properties of bonding, properties of metals. Okay, so these are the properties which are written. Number one, they have high melting and boiling points. So why they have high melting and boiling point?
Because they're solid and their atoms are really
Tightly packed. Yeah, very good. What about the force of attraction between their particles?
Teacher is very strong.
Yes, the force of attraction is very, very strong. Okay, very strong attraction. So we need a very, very high temperature or high heat energy to overcome these forces and to turn them into liquids and gases. Okay, because liquid and gases particles, they have a loose arrangement, so we have to break the force of attraction between them. And the force of attraction in metals is very, very strong. Okay, that is why the melting temperature and the boiling temperature is very high, because we need high temperature to break these forces. Okay, number 2 point is they are good thermal and electrical conductors.
Teacher, because
Electricity.
their atoms are packed very tightly so that the electricity and the heat can pass very easily.
No, because of the tight structure, no, this is not a reason for the electrical conductivity. One can think that if because they have a tight structure or they don't have any space between them, that's why there is no space for the electricity to pass. So if we think of this reason, then it should be a metal should be a bad conductor. But metals are good conductors. For this one, I will tell you the reason, that they have free electrons. Okay, and when the electrons move, then they carry current. Okay, and electricity. That I
So,
will tell you
teacher,
in the
you mean they are not
metallic
tightly
bonding.
packed?
They are tightly packed, but they have loose electrons. They have free electrons to move. And when these electrons move, then they pass electricity. Okay. We'll study it in
Okay.
metallic bonding after that. Okay. After this, when I explain you metallic bonding, then I'll tell you that why metallic bonding explains the electrical conductivity and how it explains. Okay. They have a tight structure, but this is not the reason. Okay. For good electrical conductivity. Okay. And thermal means, thermal word is used for
Hot.
heat. Yeah. Heat or hot. Okay. They are hard and dense. Hard structure. Dense means
Heavy.
very good. Heavy. Okay, more dense means heavy, more heavy. Less dense means light in weight. Okay, so aluminium. Okay, aluminium is a metal. Okay, it's a solid, but aluminium is used to make airplane bodies. Airplane bodies. And airplane, we know that airplane has to fly. Okay, so aluminium is less dense. Although aluminium is a metal, it's a solid, but it is less dense. It's light in weight. That's why it is used to make airplane bodies. Okay. Number 4, it can be hammered into shapes. They are malleable. Okay, the word is used for malleable. So metals are malleable. Malleable means they can be hammered into shapes. We can hammer them and change them into different shapes. Then the last property is they are ductile. malleable and ductile. Ductile means they can be turned into sheets and wires. They can be drawn out into wires, okay? Wires plus sheets. Means we can make the metal sheets and metal wires also. This property is known as ductile. Okay, and you should know the definition of malleable and ductile.
Teacher, did you put a cross or is it a plus sign?
A plus plus. It's not a cross.
Okay.
Yeah, it's plus. Wires plus sheet means ductile is in your book. It's written only about wires. It can be drawn into wires, but it can also be drawn into sheets. Okay, so ductile means.
Teacher, what does sheets mean? Like what do you
Sheets
mean that they can
like papers.
be turned into sheets?
Sheets means paper, like foil paper. Have you seen the aluminium foil? That's a sheet, right?
Yes, I have seen.
Aluminium sheet. So.
Yes. Okay.
So these are
what does ductile mean?
Ductile means this. They can be changed into wires and sheets. Metals can be changed in, like they can be made into wires and they can be turned into sheets. Okay, we can make sheets out of them. We can make wires out of metals. Means they are hard, okay, but we can melt them and change them into different shapes or sheets or wires. Okay. So malleable word is used for shapes. They can be turned into shapes, and ductile word is used for wires or sheets. Okay, these are the properties. Okay, and you have to learn these properties. Okay, do you remember all the properties of metals? Any ideas we have about the bonding and structure of metals must be able to explain their properties. Metals have giant structures. Okay, giant we all know. Giant means um, huge structures. Good. So metals are big. They have a big structure. Okay. Now we will discuss metallic bonding. Okay. Metallic bonding is this. Okay. This is the explanation of metallic bonding in your book. Okay. But first, I will explain you. Okay. That what is it? I will draw it on here on the page. So metallic bonding is that the bonding in the metal. Okay. And this bonding in the metal is by losing electrons, because we all know that metals have the property to lose electrons, right? In ionic bonding, we saw metals and non-metals, and we discussed that metals give electrons to non-metals. So metals always lose. Okay, so this property we will use here. That metals lose the electrons, but there is no one to take that electron. Okay, there is no one to take that electron, so the lost electron, it just moves randomly into the area. It starts moving into the area, into the whole structure. Okay, let's take the example of, for example, sodium. Okay, simple element, sodium. So if we have bottle of sodium, okay, if we have like sodium, solid sodium in a bottle, sodium blocks, and we take out one block from it. So does this one block of sodium metal, it contains only one atom or lots of atoms?
Lots of them.
Lots of atoms, yeah, good. Lots of, because atoms we cannot see. Okay, the big block or the chunk, we can see the chunk. Okay, but that chunk or block is made up of lots of small, tiny sodium atoms. Okay, now how these atoms are held together, this is explained by metallic bonding. Okay, now this is sodium atom. I'm making small sodium atoms. Okay, sodium atom, sodium, lots of sodium atoms. Now what happens, that these sodium atoms, when they come together, they lose their electrons, outermost electrons, because metals have the property of losing. Okay, so sodium, it has total 11 electrons. Its configuration is 2, 8 and 1. So how many electrons it will lose? 1. So each sodium will lose 1 electron. It isn't bond. You just give a name, bonding. Okay, because this is a bonding, but there is no compound formation. It's only mixture. Okay, they're grouped together. You can say that's a collection of sodium atoms. Okay, so sodium will lose, means from the outermost shell, its electron from the outermost shell comes out. Okay, so each sodium will lose its electron. Okay, and this electron, because there is nobody to accept the electron, so this electron will start roaming around. It will start moving into the whole space, the area which is available, because we know that electrons are moving.
Teacher, I don't understand this. Can you explain
Huh?
this again?
Yes, then sodium will get positive charge. Okay, listen, I will repeat it.
Teacher, I don't understand this.
I'm repeating, beta, wait. I'll repeat. Okay, metallic bonding is, why it is happening? Okay, beta, metallic bonding is in which the metals lose their electrons. Listen carefully now. Okay, metals lose their electrons, but no one is there to accept the electron. Okay, so when lots of metal atoms come together, when they are grouped together, all of them lose their electron from their outermost shell. Okay, so sodium, it has
Yes.
2 electrons in its first shell, 8 electrons in its second shell, and 1 electron in its outermost shell.
Miss, your voice is lagging a lot.
Yes, teacher, your voice is lagging.
Okay, so from the,
Teacher, I can't hear you at all. Your voice is lagging a lot. Teacher, your voice is gone.
Yes, Miss, I can't hear you.
girls, can you hear me?
Yes, Miss, now we can
Yes,
hear
miss,
you.
there's a
Okay, and what about the
Okay, and what
screen?
about the screen? Yes, Miss, we can see the screen.
Yes, teacher, I can see the
anybody
screen.
there?
But teacher, there's a lot of background noise.
Now?
Teacher, I can't hear you at all.
Teacher, there's a lot of background noise.
Okay, turn off your mic, all of you. Please turn
Teacher,
off
I
your
can't
mic.
hear you.
of your mind? Now tell me. Is it fine now?
Your teacher.
Miss, your voice is gone again.
Teacher is gone.
Can you hear me?
Yes, Miss. Yes,
Yes,
Miss.
teacher.
Now it's fine.
I can hear you.
Is it clear?
Miss, can you again share your screen?
Yes, teacher.
Okay,
it's
never
fine.
mind. Yes, Miss, it's clear, and we can also see your
I'm
screen.
sharing it.
Miss, we can also
Yes,
see your
teacher.
screen.
It's visible.
Let's see.
Something happening with the projector, right? Yeah, it keeps on closing. Why is it happening? Wait. It's giving heat a lot. Oh. I don't know why. It's becoming too hot.
No problem, teacher. The period is almost about 21 minutes.
Yeah, it's
Yeah, the
almost
class
ended.
is over.
Yeah, the class is over, but yeah, I gave you the introduction of metallic bonding, so inshallah we'll continue in the next class. So please
Okay,
read
Miss.
this page, okay? Over the weekend, just go through page 96. Read the metallic bonding. Fine?
Allah Hafiz.
Yes, teacher. Okay.
Okay. Allah Hafiz.
Allah Hafiz, Miss. Have a nice day and
Same
weekend.
to you. Let me see what's going on with. Okay, you can also go. You were waiting for my instructions. Allah Hafiz. Bye bye.